Today we are here to do a case study on the topic trees of data structures. So what do you mean by tree? A tree is a collection of nodes. That collection may be an empty or n-1. We have various types of trees. First of all, let me tell you what do you mean by the trees and its three terminologies. So the three terminologies, we have root node, child node, leaf, sibling, path, length, depth, height, degree and level. So root node means the root node represents the starting of the node, and it is the root of the other nodes or it is the main features, and it has the classification which is called as child node, and that child node has various classifications which is called as leaf nodes. Then after is siblings. Siblings represents the two terminologies, and after we have path, the path in which the trees travel, and then the length of the trees, the depth, its size. The depth represents the size of the tree levels, then after heights, then degrees, then level. So tree traversal. So the tree traversal means tree will be traveling, which is known as tree traversal. Traversal refers to the visiting of a node in a tree only one time. It visits the node only once at a time. Okay. Then after we have three types of tree traversals, which is in order, pre-order and post-order. In order, we have left subnode. Then the left subnode traverses to the root node, and then the root node traverses to the right subnode. In pre-order, we have root node. The root node will be traversing to the left subnode, and the left subnode will be traversing to the right. So then we have post order. In post order, left subnode will be traversing to the right subnode. Then after right subnode will be traversing to the root node. So let's know more about binary trees.
Binary tree is a tree in which no node can have more than two children. So types of binary tree: fully binary and complete binary tree. A representation of binary tree: linear representation and linked representation. So difference between general tree and binary tree. General tree, it has any number of children. Binary tree, it doesn't have more than two children. Fully binary tree and complete binary tree. So what is meant by fully binary tree? There is no compulsion of every node must have child, but the node which have child, it must be two. Complete binary tree, at all the levels there must be two child. Linear representation and linked representation.
Linear representation. Elements are represented using arrays. For every element in position I, the left child is in position 2i, right child 2i plus 1, and the parent in position I by 2. Linked representation. Elements are represented using pointers. Each node in linked representation has three fields: pointer to left subtree, data field, pointers to right subtree.
Expression tree. The expression tree happens to be binary because all the operations are binary. We can evaluate an expression tree T by applying the operator at the expression tree. The expression tree happens to be binary because all the operations are binary. We can evaluate an expression tree by applying the operator at the root to the values obtained by evaluating the left and right subtrees. Steps to construct an expression tree. Consider a postfix expression. Read one symbol at a time from the postfix expression. Check whether the expression tree. The expression tree happens to be binary because all the operations carried out here are binary. We can evaluate an expression tree by applying the operator at the root to the values obtained by recursively evaluating the left and right subtree. Steps to construct an expression tree. Consider a postfix expression. Read one symbol at a time from the postfix expression. Check whether the symbol is an operator or operand. If the symbol is an operand, create one node tree and push a pointer onto the stack. If the symbol is an operator, pop the pointers from the stack, namely I1, T1 and T2, and form a new tree with operator of the root and T1 as left check, T2 as right check. Pointer to new tree is pushed onto the stack. Thank you.